All right, we're going to start with factoring practice number 2. So let's go ahead and let me zoom in for us. Okay, so to do factoring when a equals 1, the first thing that you have to do, you have to have the a squared value a positive. And once a squared is positive, then you're free to move everything over to the same side. So in this problem in particular, these answers need to be over where they're going to be with a squared. So when we move them, we are left with a squared minus a minus 90 equals 0. Now, the a equals 1 method is a shortcut to factor by grouping. And I know that some of you guys love factor by grouping, and that's totally okay. But for the sake of the ACT, you need to do what is faster. And the shortcut for the a equals 1 method is faster than factor by grouping. So what you're doing is you're looking for two numbers that multiply to the c value, negative 90. And those same two numbers have to add to equal the middle term, which is negative 1. Another issue that I am seeing with finding the factors, I guess is how we'd say it, is we don't know how to do it the quickest way. You always want to start with the number. So this number is 90. I'm just going to start dividing. 90 divided by 2. 45 and 2, can I ever combine those to get 1? No. And then I'm just going to continue the trend. 30 and 3, I can't add or subtract those to get 1. I'm going to try 4, I get a decimal. I try 5, I get 18 and 5. That's not going to combine to 1. Eventually, I'll get up to 90 divided by 9, and I get 10. So 9 and 10 are my numbers. Then it's time to decide which one is negative. So looking at your problem here, we know when we're adding that we want our answer to be negative 1, which means the 10 has to be the negative. And then to finish this problem, the reason it is so much faster than factor by grouping is because when the a term is equal to 1, you can go ahead and just break it up. I'm going to write a and a. Then these terms I just put down here. So positive 9, negative 10. Then from here, this actually still equals 0. If there's an equal sign in your problem, then you must solve it. If there is an equal sign, then you actually have to solve the problem. So I'm going to do a minus 9 or a plus 9 equals 0. A minus 10 equals 0. Solving this problem, I'll subtract 9. So a would equal negative 9. And then I guess I probably shouldn't put a slant. I don't want you to think it's a fraction. A comma is what I should have put. Adding 10, I would get 10. So this is my answer. Let's try number 2. So on number 2, again, we want this value to be positive, which means we have to move everything to the left. X squared minus 15x plus 50 equals 0. Looking for two numbers that multiply to equal positive 50. Those same two numbers have to add to negative 15. Those answers are negative 10 and negative 5. Now, since a is 1, I'm going to jump down into my parentheses. X minus 10, x minus 5 equals 0. And bring in the equals. Setting both of them individually, I would get x minus 10 equals 0 equals, and then x minus 5 equals 0. Adding 10, I would get x equals 10. Adding 5, x equals 5. So you can write this as 10 comma 5. You can leave them separate. Both of these are correct. All right, for the very last one, v squared has to be moved, so I'm going to add it. So I get positive v squared minus 7v plus 10 equals 0. I'm looking for 10 numbers that multiply to, or two numbers that multiply to 10, and those same two numbers have to add to negative 7. So going through my numbers, remember there are shortcuts to finding factors. I'm going to start at 10 and just start dividing. 10 divided by 1 is 10. Can't combine 10 and 1 to get 7. So now 10 divided by 2 is 5. There is a way I could combine 2 and 5 to get 7. So those are my two factors. So 2 and 5, 2 and 5, and then we analyze our negative signs. So for this case, we have a negative 7, which means both of these values have to be negative. And when I multiply those, I do get a positive. So from here, again, since a is 1, I'm going to break it up into my two parentheses. V minus 2, v minus 5 equals 0. Setting them both individually equal to 0. I get v equals 2 and 5. Remember, the goal of this is to factor as fast as you can, and this is honestly the faster method, okay? This is faster than factoring by grouping. So I just want to make sure that we're able to recognize quicker methods. Now, when we get down to the factor by grouping section, notice how I have to move the 4, so I get 3n squared plus, nope, that's wrong. Let me move that. We want to make sure that the negative 8n is in the middle, plus 4 equals 0. Notice how the a value is not 1. That means you have to do factor by grouping. So I want to make sure that you know the difference and know when to use what. So factor by grouping, whenever you do factor by grouping, it's a little bit longer than the a equals 1 shortcut. So to start, the difference is basically on a equals 1, the reason that you can just multiply to get the c value is because the first term is 1. However, when the first term is greater than 1, you actually have to do a little bit more math. It's called the AC method. You're still looking for two numbers that multiply. However, instead of it just being the c value, you have to do the a times the c value. So 3 times 4 is 12. That's why it's called the AC method. Then this second part is still the same. I'm still looking for two numbers that subtract or add to equal negative 8. So when I'm coming up with my factors are 6 and 2. And in order for them to add to negative 8, they both have to be negative. And when I multiply the double negative, I get a positive. From here, I think this is the most confusion that we're having in class, and we're unsure of where to go or what to do. I think this is where the confusion comes from. When you go to this next part, the main difference from the first factoring piece right here, when you could just break it down, the difference now is that this value is not a 1. So what you're going to have to do, you're going to write down these two terms exactly how you see them. 3n squared, leave some space, plus 4 equals 0. Okay, these values, this pen smears when I highlight, these values are identical. You just bring them down. However, we are not going to write negative 8n. The whole point of the factor by grouping is to actually break up the negative 8n into the two factors that you found, negative 6n minus 2n. So what's happening here is we are breaking down the middle term so that we're able to do factor by grouping. So whenever we group, we want to group 2 and 2. So I'm going to group here and here, here and here. Now we're looking for GCFs, okay? Now we have to find the GCF. So looking at the first term, I can pull a 3 out of both of those as well as an n. So 3 divided by 3 is 1, n squared divided by n is n, minus 2. Remember, you want this parenthesis to match over here. So the goal is to get matching parentheses. Notice here as well that I have a positive n, which means I need to pull a negative 2 out from here. And I'll be left with n minus 2. Now, the reason that this is minus 2 is because when I do 4 divided by negative 2, I get negative 2. Now these are the same, so I am good. From here, let me go ahead and just grab a different color pen. I have 3n and negative 2n. Those come together and form their own parenthesis. Then I have my GCF values. I have this one here and this one here. Or not my GCF, I'm sorry, what's left after you pull out the GCF. They bring down and write their own, equals 0. Now we're going to solve it. So you set this part equal to 0. So when I do that, I would add 2 and divide by 3 to get an answer of 2/3. Add 2 and an answer of 2. So factor by grouping is not as difficult as it looks. It just takes a little extra time. That's why if your a value is equal to 1, you need to do the shortcut method, okay? So next from here, I get 5n squared plus 19n plus 12 equals 0. Now, again, I'm looking for my factors. 5 times 12 is 60. I'm looking for two numbers that multiply to 60, and those same two numbers have to add to 19. Again, if you're having issues finding factors, just practice, okay? So 60, and I'm going to just start dividing. Okay, I'll pick 5. 12 and 5, I can never add in order to get 19. So let's go down 1. I got 15 and 4. That can give me 19, which means that right here, I'm going to have 4 and 15, 4 and 15. Again, we're going to follow the same method. Remember, the A piece and the C piece stay the same. 5n squared, positive 12 equals 0. However, we're breaking up the negative 19 with or positive 19 with the factors that we found. That's why we found them, okay? That's the whole purpose of them. So instead of writing 19n, I'm going to write 4n plus 15n. And it does not matter which one you write first or second, okay? Then I'm going to group. First two, last two. GCF here is an n, so I am left with 5n plus 4. GCF here is a 3, so 5n plus 4. Again, the goal is for these two to match. If they don't match, that means you haven't either found the right factors or you didn't pull out a big enough GCF. Now we group the GCFs together and then write the repetition parentheses together one time. Set them each equal to 0, so n is going to equal negative 3 because I subtract 3. And then right here, I would subtract 4 and divide by 5, leaving me with negative 4/5. Okay, for the very last factor by grouping one, again, I want this value positive, so I have to shift everything to the left. 2v squared plus 11v plus 5 equals 0. Looking for two values that multiply to 2 times 5, which is 10. Those same values have to add to the b term, which is positive 11. Those values are 1 and 10. Again, remember the whole point of finding them, we don't find them and just forget about them. The whole point in finding those values is when we write this part here. Bring down the 2v squared, bring down the positive 5. From here, instead of writing 11v, we are just going to write the factors. Plus 1v or just plus v plus 10v. Okay, that's all we're doing. Now we have 4 terms to group. I can only pull a v out and I'm left with 2v plus 1. Here I can pull a 5 out, leaving me with 2v plus 1. Again, group the GCFs. Group the repetitive parentheses. I don't know why I wrote an I by accident. There we go. Equals 0. Since it equals 0, we have to make sure to solve. So v equals negative 5 or v equals negative 1/2. Notice the difference between the two, okay? Factor by grouping, you actually have to work to get these double parentheses. If a equals 1, you can jump straight to it, okay? That's the main difference between the two. Remember, the goal is to make life simpler, okay? Making life simpler. All right, perfect trinomials are an even more shortcut to some of your other factoring methods, okay? If you haven't learned perfect trinomials, we're going to talk through what it means to be a perfect trinomial. The first requirement is that it's a trinomial, and it is. Requirement number 2 is that these two values must be perfect squares. So if I square root 100n squared, I get 10n, so that is a perfect square. If I square root positive 9, I get 3, so I'm good. The other requirement is that this piece right here must be positive, and it is. And the last requirement is that the b value must equal 2 square root of a times c. So you're just going to test it. The b value is 60. You're going to ignore the negative. The negative comes in later. A is 100 times c, which is 9. So 60 equals 2 square roots of 900. 60 equals 2 times 30. Well, that is definitely true. Now I can jump down to my perfect trinomial. Since it's a perfect trinomial, you get a squared value because if you were to ever do factor by grouping on this problem, let's say you didn't recognize it was a perfect trinomial. If you were to ever do factor by grouping, what you can do from here is when you break it up into the parentheses, you would get the same thing twice. That's why we draw the square. The way that you get your first term is by taking what the square of the first one was. So the square root of 100n squared is 10n. Then you have the square root of 9, which is 3. Again, we're not dealing with the sign yet. The way that you determine the sign is always based on what the sign of b is. So the sign of b is negative, which means the negative goes here. So 10n minus 3 squared. That's it. You would get the same answer by factor by grouping, but this is a lot faster and you don't have to worry about factors. Also, we don't have to solve it because there's no equal sign. You only solve problems if there is an equal sign, and there is not one. Next, again, I'm going to test. Square rooting the first term would give me 11n. Square rooting the last term would give me 5. To test the b value equals 2 square root of AC. b is 110 equals 2 square roots of 121 times 25. That would give me 110 equal to 110. So I know that I'm good to go to jump to the end. Again, to jump to the end, I'm going to square root the first term. So I get 11n. Square root the last term, which is 5. Depending on the sign of b, that's how I get the middle. Again, much faster than factor by grouping if you can recognize it. And the goal of the ACT is to recognize all those shortcuts. You want to save time, okay? The ACT doesn't care about your work. All right, let's hop to 9. I'm going to test. I get 6x, then 5. To test, I should get 60. I'm going to have to write to the side. I'm going to lose some space. 60 equals 2 square roots of 36 times 25. And it does, in fact, equal 60. Now I'm going to jump down here. Remember, the C value has to be positive because you have to square root it. So I'm going to jump down. First term is 6x. The sign of B is negative. Square root of 25 is 5, quantity squared. And you're finished. Factor by grouping will work on perfect trinomials, but I want you to get in the habit of looking for perfect trinomials. The best hint to help you is that the A and C value will have to be perfect squares and positives. So that's the first trick. If you recognize your perfect squares, testing this method right here won't take you very long, and then you'll be done a lot faster. All right, we're going to do difference of squares. Notice how we're not solving for the variable. There's no equal sign. So what I'm going to do here is just focus and figure out how I know this is difference of squares. Difference of squares, you can only have a binomial, which means 2 terms. And I do. I have the n squared and the constant. So I don't have a b value, which is good. You don't want that. So all you have to do is square root the values that you have, ignoring the negative. So that's important. So the square root of 4n squared is 2n. The square root of 49 is 7. You're going to break it down into 2 parentheses. I'm going to use these values, 2n and 7. The term that goes in the center, the way that you get the b term to cancel is one of these must be positive and one of them must be negative. Because if you were to redistribute it, the n term would cancel. That's it. Let's try the next one. 2 terms, both perfect squares and separated by minus. That lets me know that perfect difference of squares is the method for me. So I'm going to square root that. I get 5x. Square rooting here, I get 4y. It's okay to have different variables. So I'm going to go ahead, write my 2 parentheses. 5x, 5x, 4y, and 4y. One of them is positive, one of them is negative. Again, you do not solve because there's no equal sign. Last one, square root, I get 14n. Square rooting, I get 12. Break it down. 14n plus 12, 14n minus 12. That's all. So you're not going to use factor by grouping, no quadratic formula necessary. Don't waste your time. Okay? On the back, we're going to do some quadratic formula. Let me go ahead and flip this over. My pen bleeds through, so I'm going to get a new worksheet. All right. Again, for your quiz, you'll only need to know how to do 1 through 15. We will talk through 16 through 21. Those are just some challenge problems. Okay, so it's telling me use the quadratic formula, so I need to make sure that I move everything to one side. So I have 9n squared minus 7n plus 4. Oh, not plus, sorry. That's not going to give us the right answer. Put a minus here. Equals 0. Now, you can test it. I can try factor by grouping. So what I'm going to do is go ahead and say, okay, I'm looking for two numbers that multiply to negative 36, but those same two numbers have to add to negative 7. So you can test it. Say, okay, 36 divided by 2, 18. That's not going to give me 7. 36 divided by 3 is 12. Well, if I do 12 minus 3, that gives me 9, so that's not going to work. 36 divided by 4 is 9. There's no way I can combine 4 and 9 together to get 7, which means that there's no factors. If there's no factors, you have to use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So from here, I'm going to go ahead and just label to make sure that we know 9 is a, negative 7 is b, and negative 4 is c. So now I will substitute. Negative 7 plus or minus the square root of negative 7 squared minus 4 times 9 times negative 4 all over 2 times 9. I'm just substituting. Now, let's simplify. Negative is positive, so I get 7 plus or minus the square root all over 18. When you're doing the quadratic formula, do not type in the square root because you can never go back once you do that. So let's go ahead and from here, I'm just going to type in underneath. So negative 7 squared minus 4 times 9 times negative 4, I get 193. Now, as far as your quiz is concerned, you do not have to simplify that. This is all you have to do. No solving necessary because it's already equal to x and it's 0. No solving necessary. Let's try the next one. So I need to move the n squared, so I'm going to add it. Be very careful because on the worksheet, a lot of us mess this up and we put 7n squared. This is actually 9n squared. Again, it's underneath the quadratic formula, so I know that I cannot factor this. So I'm just going to go ahead and do, here's my a, my b, and my c. So x equals negative b, so b is 4, plus or minus the square root of b squared, so 4 squared, minus 4, times my a value of 9, times my c value of negative 16, all over 2 times 9. All I did was base my substitutions off of this. You do need to know the quadratic formula. So to simplify, x equals negative 4 plus or minus the square root all over 18. Again, I'm just going to put what's underneath parentheses in my calculator. I am not going to type the square root, and I get the square root of 592. And that's it. Let's try one more. Again, I need to move my 7, so I'm going to add 7 to both sides, giving me an answer of 8n squared plus 7n minus 8 equals 0. 8 is A, 7 is B, and negative 8 is C. X equals negative B, so negative 7 plus or minus the square root of 7 squared minus 4 times 8 times negative 8 all over 2 times 8. Again, I'm just substituting into this formula as I go. I'm going to go ahead and simplify now, so I get negative 7 plus or minus the square root. And again, I do not type my square root in my calculator because if I do, it's not going to be an easy problem. So I get 305. Also, I'm not making you simplify these radicals. The ACT's radical simplification is a lot easier than these because remember, it has to be done without a calculator. So let's go ahead and we're going to move on to numbers 16 through 21 for some extra practice. Okay, so these bottom numbers, these are honestly just for fun and just, as extra practice. So these problems, there's none of these will be on your quiz. I just wanted to give you something to test your skill. So if you just think factoring is just too easy and you want something harder, this is for you. Okay, so the first thing I'm going to do is factor out a GCF. So the GCF I see in here is N. And then I'm going to look closely at these numbers. I see 36, 316, and 224. What I would recommend is starting small. Okay, I know 2 will go into that. 2 should go into all of these. So let's bump it up because they're all even. So 2 is definitely a factor. Let's bump it up to 3. So it goes in here. 3 also, let's see, does not go into 316. So let's bump it up again. 36 to 4 is 9. 316 divided by 4, 79, that's good. And then 224 divided by 4 is 56. So that's great. So let's pull a 4 out. So once we pull a 4 out, we're left with 36 divided by 4, which is 9x squared plus 79x plus 56. Now looking at this problem, I cannot pull anything else out of these. No other values go into those evenly, which means until the end, this is basically being ignored, okay? And we're just gonna factor like we always have. Okay, so I'm looking for 2 numbers that multiply to 9 times 56, which is 504. Same 2 numbers have to add to positive 79. Those factors are 7 and 72. Remember, you can do this the long way. All you would have to do is make sure that when you are simplifying, okay, make sure when you're simplifying that you're testing whether or not they add to equal 79. Also double checking to make sure that you're simplifying everything correctly is important. You want to pull out the biggest GCF. All right, I'm going to group 1, 2, 1, 2. Again, 4n is just along for the ride. So my GCF here, oops. Okay, this is where the multivariables gets a little weird. So this is going to be x. That's my fault. I'm sorry. There we go. That's better. So the GCF, I can pull out an x, and I'm left with 9x plus 7. Over here, I want a 9, so obviously I have to pull out something with 9 in it. So 72 divided by 9 is 8, which means I'm going to pull an 8 out. Now to finish the problem, the 4n is just along for the ride. I'll group 8 plus n, and I'll group together 9x plus 7. And that's all. Let's try number 17. So on number 17, again, the GCF here is just a. So I'm left with 4p squared plus 9p plus 2. Basic factoring from here. I'm going to ignore a until the end. It's just along for the ride. 2 numbers that multiply to equal 8. Those same 2 numbers must add to equal 9. Okay, well, going through my list, 1 and 8 will definitely add to 9, and they will also add or multiply to 8. So I get a parenthesis, 4p squared plus p plus 8p plus 2. I'm going to continue simplifying here. I'm going to get a. Then as I group, I'm going to group the first 2 and the last 2. I'm going to pull out a p, so I'm left with 4p plus 1. To get a 4 in the front, I need to pull out a 2 here, and I'm left with 4p plus 1. Now I will group. A is first, p plus 2 is next, and 4p plus 1 is last. You can put these in any order that you want to, but just know that we don't have to solve this because there is no equal sign, okay? You only solve if there's an equals, and there isn't one, so you don't have to do anything, okay? On the next one, there is no greatest common factor between these, so this is just a good old factor by grouping question. 2 numbers that multiply to negative 270, 2 numbers that add to equal negative 87. Those 2 numbers are 3 and negative 90. Again, we've talked about finding factors. It just takes a second to practice. All right, I'm going to group. I have 10m squared plus 3m minus 90m minus 27. Grouping the first 2 and the last 2. I'll pull an m out, so I'm left with 10m plus 3. The only way to get a 10m is to get rid of this negative 90, so I will pull a negative 9 out, leaving me with 10m plus 3. And finishing up by grouping m minus 9 times 10m plus 3. You don't have to solve, there's no equals. All right, next one. Number 19. The GCF that can come out of every single one of these is negative 6. When I pull a negative 6 out, I'm left with 7x squared minus 51xy plus 14y squared. Now, don't be intimidated by this problem. It's nothing that you cannot do. So from here, I'm going to go ahead. I'm looking for two numbers that multiply to 7 times 14, which is 98. Those same two numbers have to add to equal negative 51. And those numbers are negative 2 and negative 49. Finding the greatest common factor is honestly just trial and error. The negative 6 along for the ride, 7x squared. Now this is where it gets a little weird. Normally we just write one variable, but we're breaking up in xy, which means I need to do it this way. Negative 2xy minus 49xy plus 14y squared. Okay, mathematically, we just unsimplified negative 51xy. Again, I will group first two, last two. Negative 6 along for the ride. I'm going to pull out just an x here, and I'm left with 7x minus 2y. To get a 7x in the first term, I need to pull a negative 7 out. So a negative 7 as well as y. So I'm left with 7x plus 2, easy mistakes, they happen, it's okay. Negative 2y. Okay. Again, these are matching, so are these. So I'm going to go ahead, negative 6, group the GCFs, 7x minus 2y. Just because there's more variables does not make them harder. All right, let's do number 20. I see a GCF of x squared. So I get 5x plus 6y. There's no way to factor this. This isn't a difference of squares. It's just finished. Okay, for the very last one. I have a negative 6x cubed, negative 23x squared y. I also have a 10y squared x. I should see, hopefully, x's in all of these. And remember, our goal is to have a positive. So I'm going to pull out a negative x here. That would leave me with 6x squared plus 23xy plus 10y squared. And this problem is exactly like number 19, exactly the same. All right, to continue, negative x, I need to multiply two numbers. That'll give me 60. Those same two numbers have to add to 23. The factors are 20 and 3. Negative x along for the ride, 6x squared plus 20xy plus 3xy plus 10y squared. Lots of stuff going on here. Let me zoom in so we can all see. All right. Again, I'm going to group first two, group the last two. Negative x along for the ride. Give myself a little more space here. I'm going to pull out an x, and I can definitely pull out a 2. So I'm going to pull 2x. I'll be left with 3x plus 10y. Down here, if I want 3x out of here, all I need to do is pull a y out. So I'm left with 3x plus 10y. Then I'm going to group my GCF, so negative x along for the ride, 2x plus y times 3x plus 10y. And you're finished.